Welcome back. Through this video, we'll understand the TCP flags. So basically, whenever you transfer any packet into the network, the packet will have several information, so where the packet can reach the destination. So generally, when you're sending any packet using TCP IP, so the data portion of each IP packet is formatted as a TCP segment. So in the picture you can see, so the IP packet will have the IP header and the IP data, and also under the IP data you can find the TCP segment. So where this TCP segment has several informations. So you can see the source port number, the destination port number, and the sequence number, the acknowledge number, and also you can see the checksum and the window size and more options you have. And basically, understanding more about the TCP header. So each TCP segment contains a header and a data. And also the TCP header contains the several one-bit Boolean field, which is also known as the flags, which is used to influence the flow of data across the TCP connection. And here you can see these are all the TCP flags, which is used in any packet which is sent from one particular device to another device. So basically, these flags are used to indicate a particular state of connection or to provide some additional useful informations like troubleshooting purpose or to handle a control of a particular connection. So there are a few types of flags are there. Sort of this here I have listed uh, the TCP flags. So which is the Syn flag that is synchronization, ACK flag which is acknowledgement, and fin flag which is finish, and RST flag which is for reset, and push that is for PSH, and URG that is for urgent. So based on the flag which is used in the packet, so your packet transfer will act in such a way. So initially, we'll also have more understanding about each TCP flags because being a penetration tester or any network, being a network professional, you should be aware about these TCP flags. So which will be helpful for you in several scenarios or several situations. And basically, the SYN packet that is used to indicate the connection is getting initiated or any packet which contains the SYN flag. So basically this particular packet is to initiate the connection or initiate the communication. And the ACK, basically these packets are used to confirm that the uh, data packet have been received, and also used to confirm the initiation request and to tear down the request. So basically when there is if there is any data transfer should happen, so basically, before data transferring, the connection has to be established. For establishing the connection, first of all, a SYN packet will be sent to the destination, and for that SYN, the destination is going to acknowledge. So after getting the acknowledge, only the source will know that the destination is available. So basically, to initiate the connection, also the ACK packet is going to be used, as well as while data transfer also, after any data has reached the target, so then each day for each data, each packet, there will be an acknowledgement, so where the packet will have the ACK flag. And coming to the RST, basically it is to reset the connection. So it is to signify the connection is down, or maybe the service is not accepting the request, or it doesn't understand the conversation, or it doesn't understand the packet. So whatever the situation is, so in that case, so that destination will give the reset packet. So where it want to disconnect or terminate the connection. So even this reset can be used by the sender machine as well as the receiver machine. So at any point of time, sender machine or a receiver machine, so they can terminate the connection by sending a RST packet. And coming to the fin, so basically this is to indicate the conversation is over and I want to uh, end this conversation. So where it indicate that the connection is being torn down, both the sender and receiver send the fin packet to gracefully terminate the connection. So basically this fin packet is sent at the end of the data transfer or at the end of the communication or the conversation. And coming to PSH, which is push, which is to indicate that the incoming data should be passed on directly to the application instead of getting buffered. So basically, when any data is transferred to the network devices, basically the data are buffered and then only the data is transferred. So where there is some urgent packets that has to be sent, something like alert packets, so these packets has to be given higher priority and that has to be allowed to reach the target as earliest possible. So in that cases, so those packet will have the PSH flag. So where these packets will not be flagged, these packets will not be buffered, so that these packets will be allowed to be delivered to the destination immediately. And coming to URG, so which is urgent. So basically this is to indicate that the data and the packet is carrying that should be processed immediately by the TCP stack. So again, this is also going to be used for giving the packet higher priority to reach the target. And here we'll initially understand how the connection is established and how the communication starts between two devices. So basically, this understanding is very much important for any network professional or a penetration tester. So we'll understand this, how the connection establishment is happening. So initially, when two computers want to send data to each other over the TCP, so they first need to establish a connection using a three-way handshake. So the first computer sends a packet with the SYN bit set to 1, and the second computer sends back a packet with the ACK. And also for that, not only with the ACK, it also responds to the SYN, so that the response will be the SYN and ACK. I'll also just a moment. Okay, and here in this diagram you can see, so basically for establishing a connection, for the sender computer sends the packet with the SYN bit set to 1, and for that the destination mission, that is the receiver mission, responds back with ACK, and also it is responding the ACK for the given SYN. And once the SYN ACK has been received by the sender machine, so then the first computer, that is the sender, replies back with the ACK saying that okay, we can start the communication. And in other words, also I can say, so basically the SYN packet is sent to a particular destination to probe a particular service, saying that hi, I want to communicate with you through the port 80. Are you available? So for that, the destination machine, that is the receiver machine, will say that yes, I'm available on the port 80, so we can start the communication. So after which the sender computer again says that okay, so we will start the communication. And once this three-way handshake is done, so then the data packet transfer starts. So when a packet of data is sent over the TCP, so the recipient must always acknowledge what they received. The first computer sends a packet with data and a sequence number, and the second computer acknowledges it by setting the ACK bit and increasing the acknowledgement number by the length of the received data. And also the sequence and the acknowledged numbers are part of the TCP header. So those two numbers help the computer to keep track of which data was successfully received and which data was lost and which data was accidentally sent twice. So based on the ACK and the sequence number, so the data are received and it is rearranged to its original position, so through which the data transfer becoming successful. And finally closing the connection. So maybe at the end of the conversation the data transfer is done. So in that case, so either computer can close the connection when they no longer want to send or receive the data. So basically a computer initiates the closing connection uh, saying that I want my data transfer is over. So for which it is going to send the packet with the fin flag, that is the fin bit set to 1. And for that, the other computer replies with the ACK and another fin, so saying that okay, we will close the connection. And after one more ACK from the source machine saying that okay, so we are in the end, so we'll stop the communication or we'll end the communication. So then finally the connection is going to be closed. And that's all for this understanding of TCP flags. So I repeat, so this TCP flag understanding, it should be uh, very what to say, you should be very much comfortable on this TCP flags. So basically this will help you to uh, make yourself a, a, a person who has clear understanding how the network communication happens. That's all for this video. So we'll discuss the remaining topics in the upcoming video. Until then, bye bye.